Hi, it's Jan Beta, and today I'm going to attempt to install a PiStorm externally in, or rather on, my Amiga 500. And I'm going to use this one, which I put in the crystal clear A1200 case in the previous video, because it's conveniently still sitting on my workbench here. And I know I'm a bit late to the party regarding trying the PiStorm, which, in case you don't know still, is this little circuit board that is designed to plug into the 68,000 processor's socket instead of that processor, and then a Raspberry Pi plugs into this Pi header here, and the Pi is running processor emulation and a couple of other additional things that are pretty fun, and acts as a replacement for the processor, and also, of course, because it's much higher computing power in the Raspberry Pi than in the original 68K processors, it can run at vastly higher clock speeds. So the estimate is that it is acting as a 68030, running between 100 and 125 megahertz. So that's plenty fast for an old school Amiga. The PiStorm is a completely open source project. You can find everything you need, including the Gerber files and bill of materials and things like that, and the software obviously on a GitHub that I'm going to link in the video description. This particular PiStorm was lovingly hand-soldered by Michael, who donated this to the channel. I'm sorry it took me so long to get to this, but now is the time. Thank you very much for donating this. And Michael also donated this Lazarusstorm, which is an external adapter that plugs into the left side expansion port on the Amiga 500 and 500 Plus. That was designed by my friend Edu Arana, and this particular one was also built and sent to me by Michael. Thank you for that too. The Lazarusstorm is an open source project as well. I'm going to link to that in the video description. And you can also buy these pre-made from Edu's own web shop in case you don't feel like soldering. This should be pretty easy to build. It's very few components. It's basically just an adapter. This PiStorm is not so easy to build because, as you can see, it is super narrow pitch soldering surface mount components. As I said, this is hand soldered. You can have your favorite PCB manufacturing house make these and pre-populate things and do the soldering professionally for you, in case you prefer that. You can also join the official PiStorm Discord. There's regularly batches of these being produced by members of that Discord and sold on there. So if you want one of these, chances are, even if the component shortages prevent these to be mass produced, so to say, there's always a couple of them for sale. And speaking of having your PCBs manufactured by a PCB manufacturer, this is a good segue to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs and also larger amounts of PCBs if you want. They offer excellent quality PCBs and the prices are really reasonable. Turnaround times are super quick usually, and delivery is fast too. I highly recommend checking out the link in the video description. Back to the PiStorm. I guess I'm just going to go through all the steps necessary to have an external PiStorm that plugs into your Amiga 500 or 500 Plus. There's a couple of very small modifications we're going to have to make this work. Of course, you can put the PiStorm in your Amiga 500, just plug it into the processor socket instead of the original processor, and plug one of the low-profile Pi models. This is actually made to be used with the Raspberry Pi 3A Plus, which is kind of a reduced in size version of the Raspberry Pi 3 that just fits under here where the processor is. I like to have the external one though, so I'm going to try that. So the very first modification is going to be shorting a little jumper on this side expansion port. This is the regular side expansion port that all kinds of expansions, hard disks, RAM expansions, things like that are available for the Amiga 500. That should open up rather easily. There we are. That's the little door. You just take that out and you can plug your expansion in. However, we have to modify a little jumper. So this actually varies a bit from machine to machine. There's a little jumper in here that we're going to have a closer look at once I have the case removed. That is actually open on this revision 6A board. There are boards where that is factory closed already or not even present, so the pins are just connected the way they should be from factory. On this one, however, this is not shorted, so we are going to have to disassemble the case again and close that quickly. And here's the little jumper we have to close. That's jumper 6. I think I want to take the keyboard out of the way for that. And you actually don't have to remove the 68000 processor for using the external PiStorm. That is going to be overridden by the PiStorm, by the external PiStorm. That's pretty neat. So, jumper, closing. Just going to make a nice little solder blob there. There we go. In theory, we can close this up again. I think I'm not going to put the screws back in yet. Just keeping this open. And there's also some jumpers on the Lazarusstorm board that we have to set. VPAJP 2 and 3 must be shorted and BRJP. So we are just going to do that and hope that's the correct setting for the PiStorm. This Lazarusstorm was designed to be used with the PiStorm, and we're using the recommended Raspberry Pi and a standard PiStorm and the standard Lazarusstorm. So we should be good with those jumper settings, hopefully. Let's see. So here's a close-up of the Lazarusstorm, and as you can see, there's our little jumpers that are designed to be closed with solder bridges. We're going to short pin 2 to pin 3 on the VPAJP jumper, and we're going to close the BRJP jumper. There we go, some nice little solder bridges on the jumpers. And basically, now we should be able to plug the PiStorm board into the Lazarusstorm. And yeah, the socket has a little notch, and there's also an arrow, and there's a little notch indicated on the silk screen. So this is the way it's supposed to go in. Yeah. And then of course we have to put the Pi on top there, on the header. But we need to do some preparations on the Pi, obviously. As I said, this is a Raspberry Pi 3 model A+, which is the recommended one, because it's just lower profile than the Pi 3. This should work the exact same with the regular Pi 3. But as you can see, this board is a bit reduced in size and has only one USB port, which we're going to have to use. It has a full-size HDMI port, which I like a lot. So yeah, this just plugs into this, like so. There's a little PiStorm sandwich. Let's prepare the SD card for the PiStorm, which shouldn't be that difficult. I have this 32 GB one spare that I bought a while ago. The instructions on the PiStorm GitHub site say that an 8 GB one is fine unless you want to use large hard disk files. You heard right, the PiStorm can also emulate hard disks and all kinds of other things that we are going to take a look at in a second, once I get this working at all. So we are on the PiStorm GitHub now, which is a project that's got started by Captain Amygdala. Not quite sure how to pronounce that, I'm sorry. And the simple quick start says to download the light version of the PiOS. We are going to use the older version, which is PiOS Buster, because as far as I have read, this is more compatible. The newer version, which just came out a couple of days ago or weeks ago, Bullseye, is not quite compatible yet, I think, so we are probably going to be better off using Buster, which I'm already downloading in the background. And I have inserted my little SD card. We should have our download finished now. We're going to select, of course we have to select the file. And we have to select our SD card reader. And we're going to flash that onto the SD card. And that is going to take a while, and I have to enter my password. That's actually all we have to do on our modern PC. The rest of the install process is done directly on the Pi and then on the Amiga side of things. Okay, that's done and verified, so I'm just going to pop out the SD card and pop it into our Pi sandwich here. Ha! And at this point we can actually plug this into the Amiga. This is going to be powered through the Amiga from this point on. Yeah, there we go, that's in there. So you want to make sure that your power supply is up to par. I'm using a 4.5 amps rated original Amiga 500 power supply. These also come in 2.5 amps rated versions. These are the lighter versions that are they have a bit more oomph, so that's recommended, or an aftermarket one that has a little bit more amperage on the 5-volt line. I would certainly recommend using one of the more powerful power supplies for this. The 2.5 amps ones should work, I guess, but just in case you have other cards in your Amiga or expansions, you might run into some trouble because there's not enough juice. And obviously with just the Raspberry Pi OS on here, this isn't going to emulate any kind of processor. It's just going to use the internal processor on the Pi. So we are going to have to plug a keyboard in, and we're also going to have to connect the HDMI output to be able to work on the Pi side of things for the initial setup. Once you have this setup, you don't need that anymore, but you at least have to enable SSH, because that's disabled in the newer versions of the Raspberry Pi OS by default. Actually, there's not a lot of room, if you have the Amiga still in the case, to plug anything into the USB port on the Pi. So I'm just using this little 2.5 gigahertz stop for a wireless keyboard, which is this Logitech device, which I don't recommend. It's pretty shoddy, but it works for the purpose, I guess. Good enough to enter some commands. So we should be able to power on the Amiga and see our Pi starting up. Hopefully. Let's see what that does. Yay! The Pi gets some juice through the Amiga. And the Amiga is running as well. And of course, the regular setup of the Pi OS, you have to let that run for a bit. And it's restarting automatically. And then Pi OS, the light version, should boot up. Standard login is Pi, I believe. And the password should be Raspberry. There we are. I set the TV to the correct resolution now, so things look a bit better. We are going to do a regular Raspi setup, and that's sudo raspi -config. So this is obviously our standard Raspberry Pi setup. It's not replacing the processor at this point. We are going to have to make some settings in the system options. First of all, I'm going to connect this to my network. And I'm just entering my wireless network. I'm not going to show that on YouTube. We should have our wireless LAN now. I think we have to set up SSH. Would you like the SSH server to be enabled? Yes. And we're also going to set the keyboard localization to German, because that is where I am. German, no dead keys. We're going to do a reboot. I'm just going to use the console that we already have open instead of accessing this via SSH, but you can do that with the SSH server setting enabled, obviously. Now we want to get the Pi updated. That is just a normal update. We're now in my network, obviously, so we have internet access. And then we're not going to do the full upgrade, but we're going to install a library that we need from Git, which is libasound2-dev. Obviously, all the instructions are on GitHub as well. You probably want to read up on those instead of following my video here. And now it's time to actually install the PiStorm GitHub. So git clone, to clone the whole repository, https github.com. This keyboard is pretty horrible, as I said. Captain Amygdala PiStorm Git. Okay, let's see. Cloning PiStorm, yay! Okay, so now we have to actually build our PiStorm software. So we are changing directories to cd PiStorm. And now we just have to make. I think that's what the instructions say. So we should be building our PiStorm software now. And it's using the Musashi 68K emulator by Carl Stenerud. And it takes a while, obviously, because it's building the whole software. And we get a couple of warnings, but I don't think that's anything to worry about. So it seems we're done. So now we are going to have to update the FPGA on the PiStorm. So we need to install OpenOCD. I hope this works. Yes, I want to continue. And we should run the update by entering /sh. It should automatically detect the version of CPLD we have on the PiStorm board and flash that with the newest firmware. Okay, so this should be the installation, and probably our Amiga should, after rebooting the Pi, should be capable of running through the Pi, actually. So I restarted the Raspberry Pi. We have to log in again with Pi and Raspberry. Unless you change that, obviously. We are going to do cd PiStorm. And we're going to start the emulator with sudo /emulator. And that should start the actual CPU emulation, which it seems it did. The Amiga is resetting. So we should now be able to switch this to the RGB out from the Amiga. And we should hopefully, we should see our regular Kickstart logo appearing there. And this should now be an accelerated Amiga 500 at this point already. But we're not using any of the bells and whistles that the PiStorm offers at this point. This should be a pretty fast Amiga already. At this point, the original CPU is completely turned off and we're running the CPU emulation on the Raspberry Pi. And it seems to work fine as a standard Amiga at this point. Obviously, you always want to shut down the Pi in case you want to turn this off. And obviously there's ways to make this auto boot once you turn the Amiga on. It's going to take a little bit longer than your regular Amiga startup. Let me switch my upscaler box back to the Pi side of things. Should still be there, yeah. So the emulator, you can stop the emulation by using Control-C. So now the Amiga side should be stopped, stunned. Yeah, the drive is no longer ticking, so this is just hanging on the picture there. And we should be able to shut off our Raspberry Pi with using sudo shutdown now. And the Raspberry Pi is gracefully shutting down. At this point, I want to make some more settings in my Pi now that we got that emulation running. I'm going to restart raspi config and set the display options. It is recommended to use CEA mode 19, 1280 by 720, 50 Hertz, 16:9. Okay, and now we want to set our boot auto login, which is in the system settings, to automatically log into the console auto login. So this should now be enabled and we should reboot our Pi. Yes. And we should now auto log in on startup, hopefully. And I reduced the screen resolution because, of course, yeah, we are logged in. The Raspberry Pi needs more processing power to process larger screens. That's pretty obvious. So this should give us some more headroom for the emulated processor. And in case you want to log in via SSH, you can figure out the IP address of the Pi by entering ifconfig. That should display our IP address of the Pi actually through Wi-Fi. This IP address is the one you can reach the Pi at. So yeah, at this point we can use the Amiga as an actual Amiga and everything should work just as normal, just as usual. And we can boot stuff from the internal disk drive. So yeah, this is now basically using the Pi as a processor and otherwise acts just like a normal Amiga, which is great already. So that's the very basic setup of PiStorm. Obviously we want this to start up automatically and we also want to make use of some of the extra features that this offers. So yeah. As I said, I'm doing this for the first time myself, so your mileage may vary a bit, but I'll try to show some of the features and how to install them while I'm doing that. Let's hope for the best. Hey, and I also got my first processor emulated Guru meditation. Yay! So obviously we can now SSH into our PiStorm from an external computer if we have the IP address, which we got. We are going to use, I'm using terminal on my Mac here, should be the same on a Linux machine. If you are using a Windows machine, you have to download some third-party software to be able to access SSH connections, I think. So this is pretty straightforward on this machine, at least. 67. And it should ask me for the password, yes, which is Raspberry. And now we have our Raspberry Pi prompt here and we can start the emulator from this remote machine over my home network and do all kinds of stuff on the Raspberry Pi side of things, like this, which is pretty nice. First thing I want to do, and I'm using this excellent walkthrough, we are going to put another Kickstart file on there. And for that purpose, we are going to use an SSH file transfer software actually, because that's easier. I'm using CyberDuck here. These look pretty similar. All of them do. So this should be accessible, I hope. There we are. That's our Pi file system. And we can just copy a file that's named kickrom into the PiStorm folder here. And that should be the kickrom that our PiStorm emulator actually uses when we start that up. So I actually had to make a default configuration file in the PiStorm directory on the SD card in the Raspberry Pi. And there's a couple of demo configurations, kind of. There's one called Amiga.cfg that I just cloned and renamed default CFG. So that is the one that should be started with the emulator now by default, as the name suggests. So let's see if we get our Kickstart to start up with that option, or with the default config file which the emulator starts to look for when we start it. Let's see if we get the Amiga booting with Kickstart 3.2.1. Yeah, now it works. Okay, so I had to do a soft reset to make this completely work. Now it just boots up into the 3.2 ROM that's actually on the SD card and copied into RAM on startup. Nice! Yeah, I have SSH'd into the Raspberry Pi, and as you can see, our processor is running. We are going to quit that by pressing Ctrl+C. So now my Amiga is stalled, and we should be able to edit our configuration file. We are already in the PiStorm directory, default config. And as you can see, there's all kinds of settings. We have a setting here for the kickrom file, actually, that uses a standard kickrom file. I'm going to set the processor type to 68030. This default config file that is basically the Amiga config file that I'm using here has the expansion RAM set to 128 megabytes that are used for the Amiga side of things. And exit. And let's see if we can start our processor again. The Amiga should start. We probably have to reset the Amiga again. Okay, and this is now much faster, as you can see. Even the animation is much faster. Okay. That's a super accelerated Amiga at this point. Next step is going to be to have this auto boot each time we power on the Raspberry Pi and the Amiga. And to do that, there's actually two different ways. I'm going to use the easier but a bit slower to boot way. But there's another way to make the emulator process actually a background task. So that's going to boot up a little bit faster, but I don't think it's necessary in my use case. So I'm just going to go with the quick and dirty method of just starting this in one of the auto-run batch scripts. You have to start up Nano, which is the editor, and we want to edit etc rc.local. And this is a script that is auto-run each time the Pi is booted up. And we are going to add this line here. We are cding into the PiStorm directory, cd/home/pi/PiStorm/ and means next command in the script. And then we just put the command there to run the emulator, sudo./emulator. And yeah, that's basically it. And then we Control-X, save the file actually, obviously. And we are auto-booting this each time the Amiga starts up. So let me just sudo reboot. Actually, you can put a zeros there for zero delay, or now. That's the same, just 2 keystrokes less. So we should see the Amiga rebooting into our kick ROM. And ideally, this should start up with our emulator running. Takes some time because the Pi needs to start up, but then the Amiga should reset eventually after, I don't know, 20 seconds or so, and we should see our Kickstart screen. We see a guru meditation. There we are. So yeah, I did some tinkering in between. But now we have our Kickstart ROM 3.2 running here. I can reset the Amiga and start that up properly, I think. Yep, there we go. Okay, so now we got this auto booting to the 3.2 Kickstart ROM with the processor emulation. That's what we wanted. I failed to make a hard disk file in WinUAE. However, I found another tutorial that says that you can create a hard disk file on the Pi, from the Pi, actually. So I SSH'd into the Pi again, and I changed directories to home Pi, because that's the recommendation. So the PiStorm files are not going to be affected if I change the hard disk file. And we can use this command, fallocate -L 2016M Amiga HTF. And now I should have a file named Amiga HTF in the Pi directory. So now we want to go back into our PiStorm directory and edit our default configuration file. And actually the hard disk only works if we have some fast RAM. And we should set this to /home/pi Amiga HTF, hopefully. Reboot 0. Okay, obviously it's not auto-booting an empty hard disk file, but I think it tried at least. So we should now be able to install Workbench 3.2 from disk, maybe. Turns out I actually don't have any Workbench 3.2 disks, so I reverted the Kickstart to a 3.1 Kickstart, which should hopefully start up. So I have 3.1 booted up now. Let's see if we can see our hard disk file actually. Booting up the installation disk, which should boot up fine. Yeah, look at that. We have the PiStorm hard disk showing up there, but we don't have the other hard disk showing up there. So, of course, I have to edit the SCSI device name to PiSCSI device. Save. It's write protected, of course it is. Okay, let's see if we can see the hard disk now with HD Toolbox. There we are! Yay! So let's see. Drive name fake SCSI disk. Okay, so this is our auto-detected hard disk. And we have this now. Continue. That's our fake SCSI disk. Okay. Yeah. Superb. Okay. Reboot. Yeah, there we are. These are our two partitions that we just made. Let's format that. Trash can. Quick format. Yay! And let's format the other one as well. So that's basically how you do this. You set the type of SCSI device in your information for your HD toolbox. And this should be work. We should install a workbench, I guess. I am only doing this on Kickstart 3.1 because I don't have the disks handy and I'm too lazy to set up a GoTag to read my 3.2 disks. So I'm just going to do the installation process as you do for 3.1. I think I have all the disks for that at least. So we should have a proper 3.1 workbench installation when I come back from our virtual hard disk. Hopefully. Whey! And we finished the installation process. I shall remove the disk, I guess, and proceed. And it should reboot. Wow, okay, that's fast. What? Okay, let's reset again to see that. That is amazingly fast. I've never seen an Amiga boot up. It actually booted into Workbench. So let me try that again. Reset. Resetting. Booting into Workbench. That's literally seconds. Not even a second, maybe. Whoa. So hard disk emulation is blazingly fast. Yep, as you can see. Wow. Okay. Yeah, of course we have a really fast processor as well. And as you can see, we have this set to 68030 and running Kickstart 3.1. And we have a lot of RAM, 128 megabytes of fast RAM that's also emulated by the Raspberry Pi. And other than that, this is a stock Amiga 500. So we could totally unplug the PiStorm and have a Kickstart 1.3 standard Amiga 500 again, which is kind of amazing. And now this is a super machine just with this little sandwich wedged into the expansion slot there. That's amazing, pretty amazing. Let's reboot again, only because it's so freaking fast. Wow. Yeah, that's a pretty fast Amiga now, just with the little sandwich in there. And there's of course many more things that you can do with the PiStorm. I'm probably going to put the other things you can do in a follow-up video. In the meantime, feel free to check out other people's videos about the PiStorm and the installation process. I really wanted to point out that there's now the Lazarusstorm, which is an external adapter for the PiStorm, as we've seen. So you can basically just unplug it and have a standard Amiga 500 without any modifications, basically, except for that little jumper that you don't even have to close on all Amiga 500s. The other stuff, like RTG graphics, which are then output through the HDMI port on the Raspberry Pi. There's also an option to have network access through the network ports of the Raspberry Pi, the Wi-Fi and the actual Ethernet port, if you have one on your Raspberry Pi. Don't believe this one has one, actually. The 3B and 3B Plus models of the Raspberry Pi also have a dedicated Ethernet port, actually. And there's also an option to access the Pi side of things through the Amiga side, so you can shut this down gracefully each time you stop using your Amiga. Did I just say stop using your Amiga? When is that? Never. I think that's it for this video. I hope you enjoyed this little walkthrough of the basic installation of the PiStorm software. There are more recent projects like Emu68K, which is kind of like the PiStorm software we just installed, but it's bare metal software, so the processor emulation is even faster, so probably that's going to be for the next video as well. I'm definitely going to check that out. Sorry if I couldn't cover everything in this single video. I spent so much time with this, getting this working, as you've probably seen with some adventurous cuts in this video. I hope this wasn't too confusing for you. I'm a bit confused, but I got this running to this point and I'm pretty happy. I'm definitely going to tinker with this some more in future videos. Thank you so much for your support on Patreon and on the channel memberships page, and also for your single donations on Ko-fi and elsewhere. Thanks Michael for soldering together these boards for me and sending them. And thank you all for watching. Hope to see you again on this channel. I'm Jan Beta. Thanks for watching. See you next time. Bye.